This video is a continuation to the previous one. We want to see what is the impact of the component tolerance on the measured voltage when we have unbalanced conditions. So if every leg or every resistor has 1 kilo ohm, okay, so we are in a balanced condition as we have seen last time, and then because of the tolerance in the component we have here around minus 14 millivolt. Now let's go back to the previous situation when we have unbalanced conditions, and R2 now is not anymore 1 kilo ohm, but it is increased by 1%, so it is 1 kilo and 10 ohm only. Okay, so if you do the calculation, this is we did that before. The voltage we are supposed to get is 24.9 millivolt. This is the voltage that we are supposed to get here under unbalanced condition. So let's see how much we are getting actually in measurement. So this is my Wheatstone bridge here, and here I'm adding the 10 ohm resistance. So let's do the measurement and see how much voltage we are getting here. So if we do the measurement here, so we are getting 11.7 millivolt only, while we are supposed to get around 25 millivolt. So we have a huge error, more than 50%, because of the minus 14.56 we have it when the system was completely balanced. Due to the tolerance, we have this problem. Now, what if the change in R2 is not equal to 1%, but it is 10%? Okay, so here we will have a resistance. I will add it here now, 100 ohm instead of 10 ohm. So we have a change here in the value of R2 by 10%. So what is the theoretical value for that? So if we do the calculations again, using the same formula, okay, so the voltage we are supposed to get now R2 increased to 1100 ohm. So the value we are getting here now is 238 millivolt. This is the voltage we are supposed to get. So let's do the measurement now and see how much voltage we are getting. We are getting around 227. This is a 5% error. Okay, so what does this lead us? The problem in the tolerance in the resistors can be very significant when the change in the resistance of the sensor is very, very small. And this is applicable to a sensor like the strain gauge. The strain gauge, as you will see in the videos that will come after that, the actual resistance goes from 120 original value to 122, 123, so you have only 2-3% change. However, for a sensor like the thermistor that we will see again in the future, the change in the resistance is significant. So a small change in the temperature will lead to 20-30% change in the resistor. So when the change is like that, any tolerance in the component will not impact the value of the measurement as badly as it does when the change is very, very small. So in conclusion, you have to know what is the phenomena that you are measuring. If you are measuring something that changes a little bit, then you have to make sure that the tolerance in the component is very, very small. However, if the change in the resistance that you are measuring is relatively high, then you don't need to pay that much attention to the tolerance problem.